F equals MA exam 2020B, problem 2 basically says, if you have a uniform rod of length L and mass M, then the moment of inertia of the rod is ml squared over 12. So then the question itself is a square plate with side length big L and mass M, and it's uniform and it has a uniform density, then what is the moment of inertia of this square? And not on any axis. On the axis that goes straight through its center, or the diagonal axis. Oh, and I forgot to mention one thing. The moment of inertia of the rod is only when the axis is perpendicular to it. It goes straight through its center. Is our diagram. Here is x-axis, y-axis, and the z-axis. We're just going to take the center of the square and put it in the center over here. And then just take the four sides and draw it like this. And notice how, if we're taking IX and IY, all we have to do is basically look at the side that is parallel to the x-axis. And then, for example, this side, when we're calculating its moment of inertia about the y-axis, we can treat it like this rod, because the y-axis is perpendicular to it, and since the center of the square is in the center of the graph, or at the origin, then just like this axis, the y-axis is also bisecting it. So that basically means that I in the x direction, or I along the x-axis, is ml squared over 12, and I along the y-axis is ml squared over 12 as well. And then adding those two together to get IZ going to give you ml squared over 6. But we're not done yet, because we're looking for the moment of inertia along this diagonal. So what we have to do is rotate this these axes, the x and y axes, 45 degrees along the z-axis. Now, I'm not very good at visualizing 3D coordinates, so instead I'll just rotate the square 45 degrees. Good enough. So, this is the x, y, and the z. So now, what we are going to see is that both the x and y axes are right along the diagonal of the square. So we can just calculate either one of those and call it a day. So, once again, since the position of the z-axis has not changed, IZ is still ml squared over 6. It's the same axis. But now, we can call this x prime and this y prime, I guess. IZ is still equal to IY prime plus IX prime, because it's still perpendicular to both of these. So, now, all we need to do is find that this is ml squared over 6, and then we simply find that IY prime and IX prime are the same, because they're both along the diagonals of the square. So by symmetry, they have to be the same. So we'll just call that 2I prime. So I prime, which was the I squared that we were looking to find originally, is just ml squared over 12. And let's substitute the big M, the big L in there, and that gets us our answer. ml squared over 12.